In today's lesson, students begin to investigate using place value understanding in order to multiply multi-digit numbers. Today, we just started with whole numbers in increments of tens, hundreds, and thousands, and multiplying them by a one-digit number. This learning goal is something that we will be working on for the rest of the chapter. And so our goal by the end of the chapter is building on all of these strategies so that they can multiply a 4-digit number by a 1-digit number or two 2-digit numbers. So today we started looking at a strategy in order to build understanding. For a warm-up, students began skip counting by tens. And so skip counting 10, 20, 30, 40. This is like multiplying by tens because when we learned about multiples and we skip count, we realized that 10 is 1 times 10, 20 is 2 times 10. If we kept going, 30 is 3 times 10. It's the counting numbers, 1, 2, 3, 4, 5, and we're multiplying by 10 each time. So today they're looking at patterns where they realize that 1 times 10 is like 1 times 1, and we have a 0 at the end. 2 times 10 is 20. We're looking at the patterns with zeros. Skip counting by 100 is the same thing, except now if we're skip counting 100, 200, we have 1 times 100, 2 times 100, and we're looking at the zeros. Same thing with thousands. So that will help them with solving problems today and looking for strategies. This was our first problem we started with. Each car on a train has 200 seats. How many seats are on a train with 8 cars? So starting to look at and understand that multiplication is equal groups. Usually we see this term each. So each car has the same number of seats, and we know how many cars. We know there's 8, and we want to know the total number of seats. So students started investigating and solving this problem in different ways, and then we looked at several strategies that weren't discussed within the class, and some of them are utilizing base 10 blocks that we've been learning to kind of model with tens, ones, tens, hundreds. So the problem was 8 cars and each of them have 200 seats. So to model that with base 10 blocks, it's really like saying 8 rows of 200 or 8 groups of 200. We represent hundreds with rectangles because they represent the flat, the model that we have, or the manipulative we use in the class. And so to do this, we have 1 row here of 200, 2 rows, 3 rows, 4, 7, and 8. In this model, I have 8 rows. Each of them have 2 flats or 200s, representing those squares with base 10 blocks. We've talked about renaming numbers, and so I can group 10 of these and trade them in for 1,000, and we represent 1,000 cube in our base 10 models with a T in the rectangle. And then the rest left over is 2, 4, 600, 600s. So the answer with our base 10 blocks for 8 rows of 200 is 1,600. Looking down below using place value, this strategy probably isn't one that the students immediately looked to or used on their own, but just a review of place value and words kind of representing the values. 8 times 200 is really 8 times 200s, which we saw in the model. So 8 times 2 is 1600s. 1600s is really just 1,600. So there are 1,600 seats on a train with 8 cars. Utilizing a number line, if we're counting by the same number each time, we can easily draw a number line that starts with a 0. The same problem, 8 cars with 200 seats. So we're going to jump 8 times by the number 200 to represent how many seats are on a car. This would be one group or one train car with 200 seats. To get to the next one, we'd count 400, 600, 800, and we continue going until we've made a total of 8 jumps. And then we would think, where does that get us? A total of 1,600 seats on the car. The one strategy that students probably look to and use most often, because it's the most sophisticated and easiest to kind of look at and understand, is using your basic fact and just adding zeros. So it's really a pattern and mental math. 8 times 2 is 16. That's 8 groups of 2, or counting by 2 8 times. So then we can use that same strategy here. 8 times 2 is 16. 8 times 20 would be 160. And we had the kids count 8 times by 20, 20, 40, 60, 80, and so on, so that they saw that it's actually true. And 8 times 2 again is 16. So we kind of put a box around that basic fact and how many zeros? 2 zeros. So after reviewing different strategies and kind of sharing the things that we were thinking of how to solve the problem, students got this problem with Bob's Sled Shop rents 4,000 sleds each month. So every month is the same amount. It's repeating, equal groups. How many sleds does the store rent in 6 months? So using the easiest strategy with the pattern in mental math, students should realize that it's really 4,000 times 6. Putting a box around that basic fact, 4 times 6 is 24. And then we see there's 3 zeros. So the pattern is represented in the product, 24,000. Students could also count 4,000 6 times, or add, or they could do a number line and jump 4,000 6 times, 4,000, 8,000, 12,000, and so on. They could represent 6 rows of 4,000 with their base 10 blocks. For instance, one row would look like this with thousands. That's one row of 4,000. They would repeat that until they had 6, and they could count up that they'd have 24 base 10 blocks. These are all strategies that we're working on because they will build on what we're doing the next few lessons, where we're actually getting into numbers without just the zeros, the tens, hundreds, and thousands, and multiplying. We did this in our spiral, and so students looked to use that sophisticated pattern of mental math where they're using the basic fact in each problem and counting on the zeros they need to solve. If they're not sure why this is working or why we just add zeros, we can look back to the strategies that we used in the previous problems.